Welcome students. So in this video we are going to see the respiration measurement. So how to measure the human respiration. Okay. So see the image. The respiration means we are receiving the air and we are filling the air in our chamber. Then after that we are releasing the air. Okay, we are filling the air, that is inhalation. We are releasing the air, that is an exhalation. So during the inhalation, the diaphragm contracts, move down. During the exhalation, the diaphragm relaxes, moves up. Okay, so what we are doing during breathing? So we are extract oxygen during air inhalation, then we are releasing carbon dioxide during exhalation. Okay, so these are respiration. So here we are going to study how to measure the respiration rate. Rate in the sense how many respiration per minute with respect to time. Okay, how many respiration per minute. Let us enter into video.
u.com.
So respiration rate measurement. Introduction. So the respiration supply oxygen and remove carbon dioxide from tissues. So breathing is entirely controlled by the muscular action causing the volume of lung to increase or decrease. So the volume increases during inhalation and volume decreases during exhalation. Okay, so this breathing is entirely controlled by the brain, that is a muscular actions. Okay, so the breathing is subconscious mind. Okay, so this is not conscious, so it is automatically happen. Okay, right. But here in medical side, the breathing is measured in different ways. We are measuring breathing. Some patients are suffering from breathing problems, so some patients are breathe very more, and some patients are breathing very less. Even the old versions breathe is very less. The normal human breathing is around 12 to 20 times per minute. Okay, so the breathing is important thing, and some patients are suffered by head injury. At the time the breathing measurement is very important. Okay, right. So the objective of breathing is to analyze the performance of oxygen taking. Okay, right. So here we are going to see around 5 methods how to measure breathing rate or respiration rate. First one, displacement method. Second one, Thermistor method. Third one, impedance pneumocopy method. Then fourth one, carbon dioxide method. And fifth one, Apnea detector method. Okay, so we will see one by one. First we are going to see displacement method. In this method, the transducer is held by an elastic band which hovers around the chest. So displacement method is external method. Okay, we are measuring the respiration rate externally. Okay, so Here the displacement is very important. So the displacement is, that is a movement, that is we are having some movement. Okay, so the movement is adjust the resistance value, that is we are using strain gauge. Okay, the strain gauge is used. So here the transducer, that means the displacement is converted into some electrical voltage, that is a transducer is held by an elastic band which goes around the chest. So the transducer is placed over the chest and it is held by plastic tape or band in very tight manner. Okay, during the time of respiration, our chest volume, the cavity volume is increases and decreases. During the increasing time and decreasing time, it having the movement. Okay, it's having the displacement. The transducer experience some displacement. That displacement changes the resistance value. So the strain gauge is used here. So during the time of respiration, the resistance of strain gauge will change. This strain gauge is connected with that is a arm circuit, the Wheatstone bridge circuit. Its output is varying with chest expansion. Okay, this output is correspond to respiration activity. Okay, simply we can say that. So if you are inhaling the air, at the time our chest volume is increases. During the exhalation, the chest volume is reduces. Okay, so according to this process, the chest volume, based on the chest volume, the resistance value of strain gauge will change. So this change is analyzed by the Wheatstone bridge circuit and the output is varies according to the chest expansion. Okay, so this is a very simple method. This is an external method that is very easy to measure the respiration rate. Next one is a thermistor method. Thermistor means thermal sensitive resistor. So that is a thermistor. So this thermistor is placed over the nostrils. Actually, thermistor is used to measure the temperature. So this temperature measurement is used to measure the respiration rate. How? So if you are inhaling air, at the time the air temperature is normal room temperature. Then after some time we are exhaling the air, that is that air has some temperature, because the air passes inside our lungs and other area, that means our chest cavity. After that, after some seconds, it will released from the chest cavity with some heat. Okay, this heat difference is measured. According to the heat difference, we can measure the respiration. Okay, so the difference, temperature difference between inspiration and expiration, that is produce the respiration activity. Okay, the temperature is sensed by placing thermistor in front of nostrils. Okay, so in front of the nostrils we have a thermistors. The thermistor is placed by some suitable stand, the thermistor stand. Okay, the thermistor is connected with a bridge circuit. Okay, so the unbalanced signal is amplified to get the respiratory activity. Okay, right, so it's a very simple method. So we are having the thermistor like this, very close to our nostril. Okay, so this thermistor measure the air temperature. Okay, the inspired air and expired air. Inspired air is a normal temperature, it's a normal room temperature. Expired air is more than the room temperature. So this difference is calculated for every seconds. So according to this difference, we can measure the respiratory activity. Okay, so this is a thermistor method. This method is also external method. Next one is the impedance pneumocopy. So in this method, this method is an indirect method. So previous two method is direct method or external method. So this method is indirect method of measurement. The impedance pneumocopy is based on the fact that the AC impedance across the chest of patient changes as respiration occurs. What is AC impedance? AC is an alternative current. So the impedance in the sense that is resistance plus reactance. So here the reactance is considered, that means a capacitive action is considered. So here the frequency involvement also present. Okay, so whenever we are breathing, the AC impedance across the chest of the patient changes. So these changes can be measured, and every time every second these changes can be measured. From that measurement we can observe the respiratory rate. Okay, so 50 to 50 kilohertz AC signal is produced by an oscillator circuit and is given to chest of the patient through the electrodes. Okay, so 50 to 50 kilohertz signal, actually 50 to 50 kilohertz signal is produced by oscillator circuit, and it is given to the chest of the patient through electrodes. Okay, then this signal voltage is applied to an amplifier, that is we are using the differential amplifier. The block is voltage drop across the resistance. Okay, so it's a very simple method. We are applying 50 to 50 kilohertz frequency to the chest of the patient. Then we are again observe that value, that is that signal value. So this signal value is some amount of signal is dropped in the chest resistance. Okay, the remaining values are here observed. So based on the observement we can measure the respiratory rate. Okay, see the block diagram. So 50 to 50 kilohertz oscillator that produces a frequency that is connected with the patient. Then the patient by using an electrode. Okay, that means a normal surface electrode. Okay, right. Then from the patient we are connecting another one electrode, and it is given to an amplifier. That amplifier amplify the given input signal and is given to demodulated circuit. The demodulated circuit convert the amplified signal into another format, and it is given to record the data. Okay, so here the output voltage V equal to R plus R. We will see detail. So V equal to I into R plus R. Here V is the output voltage, I is the current through the chest in ampere, R is the chest impedance without respiration, and next R is change of chest impedance due to the respiration Q. Actually these are the initial, the first R is the chest impedance without respiration. Then when we are having the respiration, at the time the resistance will change. Okay, so change of chest impedance due to respiration, that is measured here. Okay, so the output voltage depends on the respiration. Okay, depends on the resistance. The resistance is vary with respect to respiration. Okay, right. So the output of the amplifier is given to demodulator and filter block. Hence the low pass filter is used to remove the residual carrier signal, that is a high frequency signal. Then the output of the impedance is that output of impedance, that is pneumocopy, contain the respirating rate data that is recorded. Okay, right. So this is a very simple method. So here we can use this method for continuous monitoring. And the next one is a CO2 method. So CO2 method is another one method that is also external method. So this method used to measure the CO2 amount in expired air. Okay, so the respiration rate can be measured by measuring CO2 in expired air. This CO2 method of measurement is based on the absorption property of infrared rays by certain Ks. Actually, the CO2 measurement is completely depends on absorption. So absorption means that is some uh, absorb. Okay, that based on that property we can measure the respiration rate. When the infrared rays are passed through the expired air, which contain certain amount of CO2, some of the radiation are absorbed by this CO2. Okay, so actually during the time of respiration, the expired air is having some CO2. That air is come under IR radiation, infrared radiation. So during the time radiation, the CO2 is absorbed by the infrared rays are absorbed by the carbon dioxide. So there is loss of heat. So there is a loss of heat energy associated with the rays. The detector changes the loss in heating effect of rays into an electrical signal. Actually, the expired air having some heat. Okay, right? Already we are in thermistor method. The respiration rate is measured. It depends on the heat temperature of inspired air and expired air. Same way, here there is a loss of heat energy associated with the rays. The detector changes the loss in heating effect of rays into an electrical signal. It is used to get the average respiration rate. Two infrared sources are available in this setup. One infrared source for test CO2 signal and another one infrared used for reference signal. Okay, so see the block diagram. So this is the diagram. Here we are having, this is infrared and this is also infrared source. Okay, so this is a chopper motor. Here we are having a disc, the disc having some holes. So this motor is rotate that disc connected with its shaft. Okay, so here two things are there, that is uh, these two things are getting gas from external. Actually this is a test gas, this is a reference gas. Okay, right. Then next one is a condenser. So this condenser absorb the infrared rays coming from the infrared source through this block. Okay, this block is filled by the gas. So this is a reference gas filled with N2 nitrogen gas. Here we are having the CO2 gas. Okay, then the infrared rays are passed through this gas. Some amount of rays are absorbed by the CO2. Some amount is transferred here. So according to the received infrared rays, this setup convert that absorbed rays, that means the temperature level, into some electrical voltage. That voltage is given to amplifier. Then amplifier amplify the given input signal and it is given to recorder. Recorder store the data. Okay, right. At the same time the amplifier output is also given to integrator. Integrator integrate the amplifier output signal and it is given to meter. Okay, so this is a CO2 method. Okay, right. Okay, so the infrared is passed through this cuvette. That means cuvette means the container. Okay, so these two are the cuvette. So this is a container. This container having the CO2. Here the expired CO2. Here we are having the reference gas, that is a nitrogen gas is filled here. So both the container is transparent one. So the rays are passing through this container and receiving here. So the condenser convert the received infrared rays into some electrical signal that is given to amplifier. Amplifier output is recorded by a recorder block, and another one amplifier output is given to integrator. That integrator connected with the meter, that is shows the respiration activity. See, the detector has two identical portions, that is a cuvette. These portions are separated by a thin flexible metal diaphragm. So that is a metal diaphragm that is connected with the motor. The detector is filled with sample of pure CO2 gas, or sometimes they are using nitrogen gas. So in our block diagram they used nitrogen gas, but we can use the CO2, pure CO2 gas, because of the absorption of CO2 in the test cuvette. Okay, the beam falling on the test side of the detector is weaker than falling on the reference side. So the beam is falling on both the side by using a different infrared source, but in the receiving side the test CO2 that side the detector is weaker. Okay, that means the infrared rays received in detector over test side is very weak when compared to reference side. The gas reference side is heated more that on the test side. So when the CO2 passes through the infrared rays passes through CO2, the CO2 gas is heated. If it is a pure CO2, the temperature level is increases. Okay, so but in a test side, the temperature level is very less when compared to reference side. The gas reference side is heated more than that on the test side, so the diaphragm is pushed slightly to the test side of the detector. The diaphragm is just moved to test side of the detector. Okay, this diaphragm forms one plate of capacitor. The AC signal appear across the detector is amplified and recorded using recorder. Okay, so the diaphragm forms the plate, okay, of the capacitor. The AC signal appear across the detector is amplified and recorded by the recorder. The amplified output is integrated and it is used for continuous monitoring respiration rate. Okay, so this is a CO2 based respiration measurement. Okay, right. Then apnea detectors. Okay, apnea detectors. Okay, so this is another one detector that is also used for continuous respiration measurement. So this it lead to the arrest of circulation. Okay, it leads to the arrest of circulation. It can be occurred at the conditions like head injury, drug overdose, etc. Okay, so this apnea detectors, that means மூச்சு திணறல். Okay, right, apnea means மூச்சு திணறல். Okay, so it is mainly for the patient suffered by head injury or the patient have drug in overdose. Okay, they will uh, they will feel the apnea. Okay, right, that is a மூச்சு திணறல். Okay, so it can also occur in premature babies. Okay, very small babies during the first week. Okay, so and after birth, the first week, the some babies are facing apnea. Okay, right. So to because of their immune nerve system. Okay, immature nerve system. Okay, if apnea persists for prolonged period, then the brain function can be severely damaged. Okay, so muchu திணறல். Okay, right. So this uh, apnea is present for prolonged period, that means for the premature babies, then the brain function can be severely damaged. Okay, so சிம்பிளாக சொல்லப்போனால் ஒரு சின்ன எக்ஸாம்பிள் சொல்கிறேன். நீங்கள் பைக் ஸ்டார்ட் பண்ணிவிட்டு உங்கள் சைலன்சர் பக்கத்தில் கொஞ்ச நேரம் உட்காந்துருந்தீங்கன்னா சிவியராக உங்களுக்கு ஹெட் ஏக் வந்துடும். ஓகே, ஏன்னா பைக் பக்கத்தில் என்ன வரும்னா, பைக் சைலன்சர்லேருந்து என்ன வரும், கார்பன் மோனாக்சைடு வரும். ஓகே, அந்த கார்பன் மோனாக்சைடு வந்து நீங்கள் திரும்ப திரும்ப ப்ரீத் பண்ணிங்கன்னா உங்களுக்கு ஃபஸ்ட்டு ஹெட்டேக் வரும். ஓகே, தொடர்ந்து பண்ணிங்கன்னா மயக்கம் வந்துடும். ஓகே, அதுக்கப்புறம் மூச்சு திணறல் வரும். மூச்சு திணறல் வந்ததுக்கப்புறம் பிரெயின் வந்து அஃபெக்ட் ஆகும். பிரெயின் அஃபெக்ட் ஆகும்போது உங்களுக்கு என்டையர் பாடி அஃபெக்ட் ஆகும். ஸோ ஃபைனலாக டெத் ஆகும். ஓகே, ஸோ அதனால தான் வந்து இந்த மாதிரி இடத்துல இந்த டிஃப்ரெண்ட் கேஸஸ் வந்து நம்மளால் ப்ரீத் பண்ணும்போது இவ்வளோ ப்ராப்ளம் நடக்குது. ஓகே, ஸோ இதான் வந்து அப்னியா அப்படின்னு சொல்லுவாங்க. அப்னியா டிடெக்டர்ஸ், தட் இஸ் அ மூச்சு திணறல் டிடெக்டர்ஸ். ஓகே, ரைட். ஸோ இதே போல் சில வேலை செய்கிறவங்க வந்து இந்த அண்டர் கிரவுண்ட் டேங்கில் க்ளீன் பண்ணுறது, இந்த மாதிரி இடத்துலலாம் வேலை செய்யும்போது அங்கே சம் கேஸ் ஃபார்ம் ஆகிருக்கும். ஏன்னா ஏர் சர்க்குலேஷன் இல்லாத ஏரியாவில் டிஃபால்ட்டாக சம் கேஸ் ஃபார்ம் ஆகிருக்கும். அதை அவங்க ஸ்மெல் பண்ண உடனே சீக்கிரமாகவே இறந்து போயிடுவாங்க. என்ன ரீசன்னா, அவங்களால அந்த ஆக்சிஜன் இருக்காது. ஆக்சிஜனை ப்ரீத் பண்ணியிருக்க மாட்டாங்க, அதர் கேஸ் ப்ரீத் பண்ணியிருப்பாங்க. அதனால் இந்த மாதிரி ப்ராப்ளம் ஆகும். ஸோ ஃபஸ்ட்டு மூச்சு திணறல் வரும், ஹெட்டேக் வரும், மயக்கம் வரும், மூச்சு திணறல் வரும், அப்புறம் இப்படி இறந்து போயிடும். ஓகே, ஸோ இது சிம்பிள் எக்ஸாம்பிள். இந்த பைக் பக்கத்தில் உட்காந்து நீங்கள் ஸ்மெல் பண்ணாலே உங்களுக்கு அது தெரியும். ஓகே, ஸோ இதான் வந்து ஆப்னியோ. ஓகே, ரைட். ஸோ ஆப்னியோ பேஷண்ட்ஸ் ஆர் க்ளோஸ்லி மானிட்டர்ட். ஆப்னியோ மானிட்டர் இஸ் யூஸ்ட் டு வாட்ச் த ஆப்னியோ பேஷண்ட் respiration rate. So very important, they must the doctors must watch this patient very closely. Okay, so apnea monitor gives two alert signals. One is audio alert signal and another one is a visual alert signal. Okay, when no respiration occurs for some particular period, some 10 to 20 seconds, so this monitor produce audio and visual signals. Visual means some lights, and audio signal means it makes some beep sound, etc. Okay, right. The input from the sensor is connected with the amplifier circuit having high input impedance. Okay, so the sensor, actually this is a block diagram of the apnea detector. So the input from the sensor is connected with the amplifier. So sensor signal from the patient, that is connected with the amplifier. The amplifier having high input impedance and a high CMR or low output impedance. Okay, right. Then the amplifier output is given into two different branch. That is, one is given to negative detector, the negative detector, after that positive detector, then comparator circuit, then lamp to show motion, lamp to indicate respiration. So the top lines indicate the visual alert. Okay, by using a lamp. Okay, so that indicates there is no motion. Okay, in the lower side here we are having the alarm circuit is present here, it produces sound. Okay, right. So here the apnea period selector is present. Okay, we will see the detailed block diagram explanation. The output of the amplifier circuit is connected with the motion respiration channel blocks. Okay, the motion channel blocks, that is a top blocks. Okay, this is a motion channel blocks. Okay, it observes the motion. Okay, right. The motion channel block differentiate motion and the respiration based on the frequency. Okay, differentiate the motion and the respiration based on the frequency. The frequency below 1.5 hertz identified as a respiration. The frequency above 1.5 Hz is identified as motion. Okay, high frequency signal above the threshold sensed by the positive detector. Okay, actually the motion can be detected by the frequency variation. So the frequency is below 1.5, that is considered as the respiration. The frequency above 1.5, that is considered as a movement. Okay, that is a motion. Okay, so high frequency is signal, that is signal over the threshold is sensed by the positive detector. Okay, right. The frequency below the threshold is sensed by negative detector. The output of the motion channel is connected with a comparator circuit. So frequency above the threshold and below the threshold both are compared by the comparator circuit. The comparator circuit produces the output that is in the form of amplitude, motion, and respiration. It compares the amplitude of motion and respiration. Based on the output corresponding lamp will glow. Whether it has a motion, suppose the frequency is more than 1.5 Hertz, then that is considered a motion, and then the motion is alert by the lamp. Okay, the lamp will glow when the frequency is 1.5, more than 1.5. If in the respiration channel we are having a low pass filter, that low pass filter is used to remove the high frequency noise signal. Okay, right. If there is no respiration, the Smith trigger circuit gives the output to switch the alarm. Okay, no respiration for some time, around 12 to 20 seconds. So the schemic trigger gives the output to switch on alarm. Okay, the alarm will make sound. So by the sound we can understand the particular patient having no breath. Okay, right. Apnea period selector circuit contain low frequency alarm oscillator and tone oscillator and audio amplifier. Apnea period selector circuit drives the alarm circuit. Okay, the output of the alarm circuit is connected with the speaker. So where there is no respiration for a period of 10 to 20 seconds, then the audio signal through the speaker and the visual signal through the flashlight is delivered. So the doctors or the nurse easily understand whether the particular patient is suffering from respiration. Immediately they will take care. Okay, right. Then in this session, actually the 4 different types are studied. Okay, so next we are going to see some gas law used. Okay, actually these gas laws are asked for 2 more questions. Okay, just we see. First law is Boyle's law. Okay, Boyle's law. Okay, so it stands that at constant temperature, the volume of gas varies inversely with temperature, with pressure. Temperature is constant. Okay, temperature is constant. Volume of gas varies inversely with pressure. So volume vary inversely with pressure. So when pressure increases, volume decreases. Okay, right? That is a normal. Okay, that is a Boyle's law. Okay, right. So here V2 by V1 equal to B1 by P1 by P2. Here temperature is constant. Okay, that is temperature is constant. So V2 is a final volume, V1 is a initial volume, P1 is a original pressure, P2 is a final pressure or initial pressure. P1 is a initial pressure, P2 is a final pressure. Okay, so this is a Boyle's law. Next one is the Charlie's law. It stands that the constant pressure, here the pressure is constant, the volume of the gas is directly proportional to absolute temperature. Actually the 3 parameters are considered temperature, pressure, volume. So if temperature constant, volume and pressure is indirectly proportional. If the pressure is constant, the temperature and volume is directly proportional. Okay, V2 by V1 equal to T2 by T1. Here the pressure is constant, V2, V1 is a final and initial volume, T1 is the original temperature or initial temperature, T2 is the final temperature. Then Henry's law. This law states that if the temperature is constant, the quantity of gas that goes into solution is directly proportional to the partial pressure of that gas. The gas with greater partial pressure which have more mass in solution. So this law states that if the temperature is constant, the frequency of gas that goes into solution, temperature is constant, the quantity of gas that goes into solution is directly proportional to partial pressure of the gas. The gas with the greater partial pressure will have more mass in solution. Okay, this is Henry's law. And the last one is Dalton's law. It states that the total pressure exerted by mixture of gas is equal to sum of partial pressure of various gas. Total pressure is equal to sum of partial pressure of the various gases. Pt equal to P1 plus P2 plus dot Pn. Pt is a total pressure, P1, P2, P3 is a partial pressure of the various gases. Okay, right? So thank you students by this session. So I believe that you are all understand about the respiration rate measurement. Thank you students. Thanks for your support. Thank you. Bye.